In this video, we're going to do a few more examples of polyatomic ion containing compounds, so ionic compounds that contain polyatomic ions, groups of atoms that are covalently bonded together but have an overall charge. We're going to do a few examples where we have the name and go to the formula, and then where we have the formula and go to the name. So over here, there's a handy trick that you can use to remember some of the formulas for the polyatomic ions for some of the common ones. So here we have Nick the camel and Brad the fish had an itch for a clam supper in Phoenix. So if you look at the words, for example, Nick, the first letter that's uppercase and bolded is going to be the first letter element in the polyatomic ion. The number of O's in the polyatomic ion will be the number of consonants. So N, C, and K. There's 3 consonants, so that's 3 O's. And then the charge of the polyatomic ion is the number of vowels in that word. There's 1 vowel, so the charge of nitrate is -1. You can do the same trick with the other words where you have bold letters in them. So for example, we can have Brad over here. So Brad, the first 2 letters are bolded, so that'll be the first 2 letters in the polyatomic ion, so Br, so it's polyatomic ion that contains bromine. And then we also have the number of O's, which is the number of consonants. There's 3 consonants in here, B, R, and D, so that's 3 O's. And then the charge is the number of vowels, is 1 vowel, the A, so that's -1. So this is the bromate ion. And so you can use this little mnemonic aid here to help you remember some of the formulas for some of the common polyatomic ions. So once again, when naming a polyatomic ion, when naming a compound that has a polyatomic ion, you simply name the metal first, and afterwards you name the polyatomic ion without doing any modifications to the name whatsoever. So let's say we had this compound here, Ca, B, R, O, 3, 2. So your first step is naming the metal, which is calcium. Don't change the ending, just write it as is. Your second step is naming the polyatomic ion as it appears. Don't worry about the little numbers here, the little subscripts, just find what the name of BrO3 is, and we just saw it by doing this example over here. So we have the bromate ion in there, so we have calcium bromate. So what this means, this formula here means, is that we have 1 calcium ion, the Ca, plus 2. And we have the little number here shows 2 bromate ions. So we have 2 of these ions here, the BrO3 minus ions, or I should say 3, and then -1 ions. And this makes sense because you know that the overall charge of an ionic compound has to be 0. And so the 2 bromates together make an overall charge of -2 plus 2, that makes 0. And that's what that formula indicates to us. Remember, the little numbers do not indicate the charge, they indicate how many of those ions are present within this particular compound or unit. We'll do an example where you have a name and you need to make a formula. So let's say you had aluminum nitrate. You're going to follow the same steps that you would if you had a regular ionic compound. You start off by writing the charges of the elements side by side. So here we have aluminum metal, and you know it's in group 13, so it would have a charge of +3. And then you have to find nitrate. So you don't have nitride here. Nitride would make this a binary ionic compound, binary, meaning 2 elements. You have nitrate. Polyatomic ions end in ate or ite, or sometimes so here we have nitrate. You have to find what that is. So if you look over here, nitrate is NO3 minus. So what I do is I put the polyatomic ion in brackets. When you're doing your crisscross, you do not want to change the subscripts on the polyatomic ion. The only thing you can move are the charges. So I leave my charge outside of brackets, -1 here. So now I circle the charges, and I do the crisscross, making sure that the numbers land outside of the brackets. Now I get aluminum 1, but I don't have to write that down, and then NO3, close the brackets, 3. If you put the 3 inside the bracket, you would have NO33, which is different from NO3. So what this tells us here is that we have one of the aluminum ions in there, an Al3+, and we have 3 of the nitrate ions, 3 of these NO3 with the minus charges. And that would make sense. If you have 3 of those -1 charges, that's an overall -3 charge. And our aluminum has +3, so together that makes 0. So we have a balanced charge, a charge balance compound or formula. We'll try one more example. If you had to reduce, you would make sure that you reduce the subscripts outside the brackets, not the subscripts inside the brackets, because then you'd be changing the polyatomic ion. So let's try aluminum phosphite. Now remember, this ends in ITE, not IDE, so you know this is not the phosphorus ion, it's a polyatomic ion, because polyatomic ions can end in ate, or and there are some examples of ide, for example, cyanide and hydroxide, but you'll see most of them are ate, or and you just have to remember which ones are the ide exceptions and the exceptions. So in this case, you'll notice that we have phosphate written down here, PO4 3-, but not phosphite. So I'm going to tell you what the formula for phosphite is, and I'll teach you in another video how to actually derive the formula or make it up by knowing phosphate. So the formula for phosphite is PO3 3-. Notice it's just one less oxygen. So you set it up the same way that you did the previous examples. Al +3, put the phosphite in brackets. The charge can be outside. Then crisscross. Charge from aluminum down, charge from phosphite down the other direction. You'll have Al3, PO3, 3. Notice because you have the 3 subscript here, since they're multiples of each other, you can reduce by dividing by 3, but don't divide anything on the inside of the bracket by 3, because then you'll be changing a polyatomic ion altogether. So you need to make sure that you're only dividing what's outside of the bracket. And that's going to give us Al PO3. Because I'll end up with a 1 outside the bracket of the polyatomic ion, I don't have to put a bracket there. So I have 1 aluminum ion and 1 phosphite ion. So here we saw an example of making a formula where we had to reduce. Make sure that when you reduce, you don't reduce anything inside the bracket. You just reduce what's outside the bracket. Otherwise, you're changing the polyatomic ion. The other rules we learned for multivalent elements would still apply. So if you have copper 2, make sure you indicate that it's copper 2, and then you just simply name the polyatomic ion. If you have a formula where you have a multivalent element in there, you need to make sure that you do the reverse crisscross or charge balancing to figure out, well, what charge a multivalent element has. Remember that you're going to recognize that you have a polyatomic ion with certain endings. Usually when you see ate, you have polyatomic ions with some exceptions like hydroxide and cyanide. So you need to remember those so that you don't think that they're binary ionic compounds. If you see phosphide, IDE, that's not a polyatomic ion, it's the phosphorus ion. So those are all tips and tricks that you'll pick up as you do more and more practice. Become familiar with this table. In the next video, I'm going to teach you how to derive different polyatomic ions like phosphite, sulfite, from ones that you might commonly see like phosphate and sulfate.